In this video, we'll talk about some of the logarithm basics. This is a really important tool that we'll learn that deals with exponential functions. So I'm just going to write here, to make that relationship, whenever you hear logarithms, you want to think about exponential functions. And they go hand in hand. In fact, they are total opposites of one another. And that's how they are very closely related. So as a recap, let's consider the situation where we are trying to solve x squared equals 16, for instance. X squared equals 4. So we know that we can do this a couple of different ways. One, we can take the square root of both sides, and knowing that x can be positive or negative, since squaring it will give us a positive number, we typically put the plus or minus out front. Okay, so we would get plus or minus 2. So that means that the value multiplied by itself that gives me 4 is plus or minus 2. Alternatively, we've looked at it this way, where we can raise both sides to the 1/2 power. Now because this is an even exponent and anything times itself an even number of times will always be positive, we still want to put the plus or minus out here when we know that the root itself is an even root. So we know that by property of exponents 2 times 1/2 is 1, so we get x to the first equals plus or minus. And if you don't know how to do, so whenever we, the alternative approach is to raise both sides to the 1/2 power, and when we do that, again, we got the plus or minus sign there because any even exponent allows us to have a positive or negative value. Remember, it doesn't matter whether you do -2 times -2 or you do -2 times -2 times -2 times -2. Every time you multiply a negative by a negative, you're going to get a positive. So -2 times -2 is positive 4, -2 times -2 is positive 4, 4 times 4 is positive 16. So we still have to be in command of the plus or minus sign here. Now if we did 4 to the 1/2 in our calculator, we would get 2. And so then we want to make sure that we say plus or minus 2 because positive or negative value would work. So that's a recap whenever we're solving for a base. And I'm going to type this out. So here the idea is that we're solving for the base. What times itself twice gives me positive 4? And the answer is positive or -2. That was our answer. That's what we came up with. So I put that into words because sometimes we forget what it is that we're exactly looking for. In this case, what number times itself twice gives me positive 4? Positive or -2 is our answer. Okay. One last interesting feature before we go into this is one rule that we have is that if anything raised to the 0 power is equal to 1, as long as x is not equal to 0. Okay, well that brings up a couple of interesting points. Why is x to the 0 equal to 1? Well, we know that anything divided by itself is equal to 1. We know that anything divided by itself is equal to 1. So it doesn't matter whether it's 5 squared over 5 squared or 5 over 5. Or this could be pi over pi. Well, pi goes into pi one time. 5 squared goes into 5 squared one time. 5 goes into 5 one time. Okay, well let's do this with a base that we'll just call x. So if we have x to the 5th divided by x to the 5th, we know that that's going to be 1. On the left-hand side, though, I know that if I divide something by itself, the rule of thumb is I can take x to the 5th over x to the 5th, which I know is equal to 1, and I can actually write this as x to the 5 minus 5. So I can take the number on the exponent on the top minus the exponent on the bottom as long as the bases are the same, and that gives me x to the 0 power. Oh, well, wait a minute. Well, that's really just x to the 5th over x to the 5th, which is equal to 1. So here we've kind of proved the relationship that x to the 0 is equal to 1. Now, why does it have to be the case that x can't be 0? Well, let's look at this. if we have x to the 0 power, that really means, or sorry, 0 to the 0 power, that really means that we started off with something like this. 0 to the 5th divided by 0 to the 5th. Well, wait a minute. But if you divide by a 0, which really is just 0 divided by 0, that's undefined. You can't divide by 0. So raising 0 to the 0 power means that you have a 0 in the denominator. So that's why x can't be equal to 0. So that hopefully clarifies that point just a little bit. Now let's look at a different variety or different flavor. We're now looking to solve this equation, which basically says 3 to the x power equals 9. Well, what is this actually asking us to do? Let's think about that part first before we try to apply rules and properties. We're looking for what 3 multiplied by itself, how many times, or x times, so how many times will give us 9. So 3 multiplied by itself, how many times gives me 9? Well, I can kind of play around with this, and I can see, hopefully pretty quickly, that 3 times 3 equals 9. So I'm going to write, I know that 3 times 3 gives me 9. So 3 times 3 is really 3 to the 2nd power. So in this case, I would have to say that x should be equal to 2. That in other words, I should multiply 3 by itself 2 times in order to get 9. Okay, well, let's look at another example. What about if we were to solve 2x equals 8? Well, same type of setting. I'd have to kind of think about 2 times 2. Well, that only gives me 4. If I multiply that by 2 again, that gives me 8. So in this situation, how many times did I multiply by 2? Well, I had 2 times 2 times 2, which is 2 to the 3rd power. So that means that 2 to the 3rd power gives me 8. And I can check this in my calculator always. 2 to the 3rd power gives me 8. Perfect. So that means I've just determined that x should be equal to 3. That my exponent on 2 should be 3, and that will give me an output of 8. Now, just to show that these can be arranged in any order, let me just put the output on the left side and the 4 raised to the x power on the right-hand side. So I'm asking 4 times itself, how many times, that's what I'm trying to answer, how many times gives me 64? Well, again, I can just try it out. I can do this way. I'll do it a different way now. 4 times 4 is 16. 4 times 4 times 4, which is 4 to the 3rd, gives me 64. So that means I've just found that the exponent, which we're calling x, should be equal to 3, and that will solve the equation. That will give me 64 equals 4 to the 3rd, which is equal to 64. So 64 equals 64. Well, of course, you can probably imagine that these can get more complicated. So let's just say we're trying to solve 0.5 raised to the what power, or 0.5 times itself, how many times will give me 0.125? Well, you may or may not see that right away, so I can do 0.5 times 0.5, which is really 0.5 squared. Now I know that when I multiply a decimal times itself, it's going to keep giving me a smaller decimal, because 50% of 50% is only 25%. Well, 0.5 times 0.5 times 0.5, which would be 0.5 to the 3rd, is 0.125. So I've just determined that x should be equal to 3. But what if I have a situation like this? 2 to the x is equal to 23. Well, I know that if I do 2 times 2, that gives me 8. I know that if I do 2 times 2 times 2, oh, sorry, this is 4. 2 times 2 times 2 gives me 8. 2 times 2 times 2 times 2 gives me 16. But if I do 2 times 2 times 2 times 2 times 2, that gives me 32. Then that's too big. So my exponent, I know, is going to be somewhere between 4 and 5. So I'm going to say x is between 4 and 5. Now, I don't know exactly where. I could start messing around with this and saying 2 to the 4.1, and that gives me 17, which is still too small, so maybe I'll try 2 to the 4.3. That's still too small, but I'm getting closer. 2 to the 4.5. That gives me, oh, pretty close. 2 to the 4.6 gives me 24, so that's too big. So now I've been able to determine that x is between 4.5 and 4.6. So what's in between 4.5 and 4.6? How about 4.55? Well, that's still a little too big, so it's got to be less than 4.55. Well, as you're probably guessing, you know, depending on how close we actually want to get, if we feel that this is close enough, 23.4, then we would stop and say our answer is 4.55. But in a lot of situations, we want to be exact, especially in math. We want to be exact. Well, this is where our solution would be to use logarithms. And logarithms were developed a couple centuries, oh, let's see, I don't want to misquote this. I believe in the 19th century is when they first started to come about. And logarithm is actually based on a Latin word called logaritmo, which basically tells us the patterns of numbers, the patterns of exponents. So let's write this another way. We're trying to solve this setting. 2 to the x equals 23. What are we looking for? Well, what we want to find is x. We want to isolate x. So I will write this statement in terms of what x is. Here's what I'll say. X is a power. X is the power. Okay, well, what is the power of? X is the power on 2 that results in 23, or that gives me 23. Okay, well, in mathematics, we don't like to use too many words. We would hope to kind of convert this into symbols. Well, a logarithm, our definition of the word logarithm is just another way to say exponent. Okay, so here's what we'll say. X is, that takes care of that and that, is the equal sign. Now the power on, I'm going to call that the logarithm, because by definition, a logarithm is an exponent. All right, so we could also have said x is the exponent on 2 that results in 23. So the way we typically write that is, we would say, is the logarithm on 2. Okay, so 2 is my base, right? 2 is the base in this situation. So to indicate that it's the base, I'm going to put it as a subscript. Now, a subscript is just a value that is below or at a lower level than the word that we're trying to describe. So x, this so far says x is the power on 2 that results in 23. Well, the place that I put that is in line with the word logarithm. Now, we don't use the word logarithm entirely, so we actually will just abbreviate it and say log base 2 that gives me 23. Okay, well, in our calculator, and this is something that comes about later on in college algebra that you'll study more, in order to be able to compute this in my calculator actually is really smart and can do things like this. I would actually, to type this in, I would have to type in log 23 divided by log 2. So you'll notice that I'm dividing log 23 divided by log 2. The reason we have to do this is because our calculator only thinks in base 10. So don't worry too much about that yet, except that in order to be able to compute this, I would have to do log 23 divided by log 2. So it's the log button. And that gives me about 4.524. 4.524. So what does this mean? I've just determined